Max, welcome to the show.
Yeah, thanks a lot for having me.
Yeah, thanks so much for being here. I'm really excited to talk about Temporal and some of the stuff that you guys are doing over there. But maybe we can start with some basics. Who are you? What do you do? And how'd you get to where you are today?
So I'm Max Fateev, and I was engineer all my life. I worked in the last 20 years. It was Amazon for 8.5 years, a couple of years at Microsoft, 4 years at Google, and then 4 years at Uber. And then we started the company Temporal, and I'm CEO of the company and co-founder.
Amazing. That's quite the the work history. A lot of heavy hitting companies there. I'm sure a lot of that influenced some of the or inspired some of the work that you did at you've been doing at Temporal. But so I want to talk a little bit about some of the challenges of systems in the cloud. I think one of the things that happens a lot of times is you end up with all these disparate systems that need to talk together and they to complete some sort of workflow or task. And back in the days when everything kind of ran on a monolith, in a lot of ways, it was kind of easier to coordinate work between different parts of the system because there was just less moving parts. But when it comes to these modern systems, I guess what are some of the challenges organizations run into in terms of attempting to automate tasks across these distributed systems that maybe are running a whole bunch of different microservices that kind of run independently?
I think when we say microservice, there are two types of microservices, really, right? There are request reply. And then the moment you say, oh, I need consistency, I need to make sure that things complete, and I cannot just return 500 error to the customer, you practically say, okay, now you are in the event-driven world, right? There is no any alternative. And then you kind of start composing all these pieces like queues, durable timers, and all of these other things. And the reality is that event-driven systems are awesome at runtime, right? Because they disconnect your services from each other, and you can get much higher availability, flow control, so queues. And just to give you some background, at Amazon, my first 5 years of career, of my work there, I was working on PubSub, practically team which owned frameworks and PubSub, and I was design lead for the Amazon messaging platform, which practically was broker-based architecture, which delivered all the messages within Amazon. And later, Simple Queue Service took it as a backend. So I know PubSub pretty well. I'm still an expert in that. Mm-hmm. But one thing you learn pretty fast that while at runtime is an awesome technology, but at design time, and when you think about your system, when you operate your system, it is extremely hard to use, and it's just raw abstraction. So events and queues are just raw abstraction when you think about your systems. And the main problems you arise with that you lose consistency across services, right? Its complexity is very, very high. And you deal with most of your logic and code is not business logic. That is kind of the main problem that you need to solve. And,
is it that you end up writing essentially a ton of your code is just to handle different conditions of these event systems where they might not respond within a certain time frame, or maybe they even fail?
It's a lot of things, right? First, most important thing is that your business logic is scattered across multiple places. So you cannot go and say, oh, okay, this is what my system is doing. You have to run that system to actually see what's going on. And then you cannot even imagine your full kind of control flow because it's just scattered. And then also certain things like compensations, sagas, or other one would be just looking where your system is become or it's practically impossible. Or cancellations, these type of features become almost impossible because the state of your system is messages in these queues and state on these databases in my services. So it's extremely hard to make sense out of your system, which makes it extremely hard to maintain and operate.
Mm-hmm. Yeah. So you mentioned at the sort of in the introduction, you've worked for a lot of, companies like AWS, Google, and so forth that have, really large sort of complex distributed systems. And a lot of those companies have developed kind of their own tooling to address some of the challenges of actually running these big distributed systems. I know from my time at Google, for example, there's a project you might be familiar with it called Manifold for sort of workflow orchestration. And of course, they also have their own version of PubSub for event-driven systems and so forth. But was your prior experience with some of these companies what inspired Temporal, and sort of how did the company start?
So actually, it started as a simple workflow service. There is AWS SWF service, and our team owned PubSub for Amazon. So I was in the middle of every design discussion on every code review, like not obviously every code review, but at every high-level review for every new service. And I was kind of advising teams how to build these large-scale distributed systems using queues or topics. And it became clear that we need an orchestrator. And we started to work on that. We were multiple internal versions, and I was a tech lead for the public AWS version of AWS Simple Workflow. And there we found that we actually were able to, as we are building AWS service, we kind of thought it through from the beginning how to make it highly scalable and available. And we iterated a lot on developer experience. And I don't think we nailed it because probably most of you still didn't hear about Simple Workflow Service. It's out there, it's still public service, but most people don't use it because developer experience wasn't actually very good. But what then happened is that co-founder of Temporal, Samar Abbas, he went to Microsoft and he worked with me on a Simple Workflow. He went to Microsoft and tried to do something like Simple Workflow at Microsoft Azure. Given that Microsoft had quite a few workflow projects back then, he didn't succeed to make it a high-level service, but he released the open source durable task framework as an open source. And then it got adoption internally at Microsoft especially so high that then later Azure Functions took dependency on that. And Microsoft has Azure Durable Functions right now based on that idea. And later we met at Uber, and we our first project at Uber was actually a pub subsystem called Jeremy. It was open source. You can still look it up, an article about that. And we realized that for that system, we needed background jobs, and we knew how to do background jobs. So we started to kind of creating something like Simple Workflow, but using completely different software stack. And then this became grew up. This project was called Cadence. And this project became successful within Uber. Within 3 years, we've got over 100 use cases running on that. And later we just started a company with the same open source. We forked the project, so it's open source project, MIT license called Temporal. And this is what we are still building as a company, and we obviously monetize that, but through our cloud offering.
Right. Yeah. So at this point, there's, I think, probably, my understanding is quite a few parts of Temporal. So you started with the open source project. Now you also have a managed service version. There's been a heavy investment on the sort of developer experience side with CLIs and SDKs. And you said that you started sort of with a simple workflow orchestration, but can you kind of walk me through some of the engineering history? Like you started with the open source project, but where did you go from there? Essentially, what was sort of the history of the project to where you are now?
So it was the Cadence project, which we started at Uber. We built it as open source from the beginning. We practically did development in the open. And I actually, Uber was actually a very cool place to do open source. They allowed to do a lot of open source. There are a lot of interesting projects out of Uber, which came out of Uber. So we are super grateful to Uber that we were able to do that. And we internally, first 2 years, we've got practically zero external adoption. It was out there. It was on GitHub. We've got some stars, but no real usage. But we had a lot of use cases internally. So we were growing that service at large scale, bringing more and more use cases and just focusing on internal Uber adoption. As I said, we've got over 100 use cases within the first 3 years of the project. In the meantime, what happened is that when we did the version of Cadence, like at Uber, we actually were able to iterate on developer experience to the point when it actually became pretty reasonable and pretty good, comparing to, for example, Simple Workflow. And three things kind of went together. First one was much better developer experience, and we can talk about that a little bit more. Second was that it was open source project. People like open source, and especially if it's MIT license, real open source license. And the third one was because we were running these systems at scale for a long time. At Uber, people trusted our code base, and we also had experience from Amazon and Microsoft. So we our experience plus developer experience plus running these things at scale allows external adoption. And when we actually got early external adoption, it wasn't from some small companies. It was from very large, very well-known companies. One of the first adopters were Airbnb, Box, HashiCorp, Coinbase. So those companies, certainly top tier companies, and they weren't adopting that for small use cases. They're adopting for very high value use cases. And this allowed us practically to start growing that community. And then when we decided to start the company, we realized that staying at Uber, we cannot really spend so much time on the external community because we obviously need to solve internal problems. And we would never get such a big team as we have now and we will have in the future. So that's why we took VC money and started the company.
Right. I think, some of the early adopters like Airbnb and some of the other companies you mentioned, I think that makes, it makes sense to me in my mind because there are going to be companies that are similar in terms of running large distributed systems. So they're going to be, I think, acutely feeling like the pain of either trying to do this themselves or not having something in place to manage this. Whereas, maybe a smaller company doesn't, isn't operating at the scale where this is, the absolute P0, top 10 problem for them to solve right now. And they're okay with, either, handling it through some sort of bespoke method or, I don't know, taking some sort of other project off the shelf to kind of put a Band-Aid on it for the time being. Is that something in terms of your original go to market you saw? It was these larger companies that sort of the pain point that you were addressing with Temporal resonated with more so than maybe the smaller companies.
We actually got quite a few smaller companies as well. I don't remember their names out of the book, from the top of my head. But I think I think it's a huge misconception about Temporal. First, we actually call it Temporal, not Temporal.
Okay,
we kind of decided to standardize on Temporal for all sort of interesting reasons. But Temporal helps you to write your code faster because it eliminates 90% of code related to reliability. And even if you're one person or two people startup in your pre-seed mode and you're building an application for your customers, but you cannot just lose data or lose customer trust by dropping things on the floor, I can guarantee you will write your application faster with Temporal than doing an ad hoc solution. I think this is important to understand. The good news is that you don't need to rewrite your application if you become successful because companies like Snapchat or Airbnb can run on that. Every Snapchat story, for example, goes for our service. Mm-hmm. And so they have very extremely high rates. So our value proposition is you write less code, you write more reliable code, your life is easier as an engineer. And at the same time, you don't need to rewrite your code if you are successful. We have right now, we have a startup program when we give credits to startups because we are pretty popular with early stage startups. It's different from a lot of other products. There are certain class of products which only are needed if you large scale, right? Or you can use Postgres, but if you outgrow single Postgres, then you use our solution, which is scales better. That makes sense. But with Temporal, doesn't apply. You absolutely get value even if it's a small deployment and small scale. We have a lot of users which do 10 transactions per day or 50 transactions per day, and they still get value out of that. So It's not about scale. It's about complexity and developer productivity.
Mm-hmm. Okay, great. Thanks for clarifying. So one of the other things that you mentioned when you were talking about sort of the recipe of success or combination of factors that led to some adoption was improved developer experience. So, and you mentioned earlier that with the simple workflow service that you developed at Amazon, the developer experience wasn't sort of at the level that, led to a lot of adoption. So what were what were sort of the challenges that had to be solved from a developer experience standpoint that you solved with Temporal that led to, success that you saw?
Okay, let me first describe what Temporal is, because we talk about Temporal. I'm pretty sure not everyone understands the value of what it actually does. Mm-hmm. Let me give you some kind of technical explanation. So if you're an engineer or architect, you probably should be able to get it. Basic idea is extremely simple. We introduce new concept. We call it durable execution. And the idea is that we give you runtime, which preserves the full state of your code, practically your runtime state of your execution. Imagine function, which function, let's say, calls three APIs, A, B, and C. You're blocked on API B, and then process which hosts this function crashes. Or network event happens when you lose all the requests. Temporal will automatically recover the full state of that function in a different machine. And all your local variables, all the stack, everything will be preserved. You still will be blocked on B, and B can return 1 day later, and you will continue to the next line of code. So practically, when you write your code, you don't even think about storing state, because state is already preserved inside of your local variables. And you don't need to think about process crashes, because we will just preserve the full state. It eliminates most of the complexity, because we guarantee eventual completion of any business logic. And you write this in the top level programming language. So we support 6 SDKs right now: Java, Go, TypeScript, PHP, Python, and .NET. And when we talk about developer experience, the most important part for us was how do we make it as seamless as possible integrated with the language. So if you're a .NET developer, how do you write this code in a way that looks natural for .NET developer? If you're a Go developer, how do you write this code which is as natural as possible to the Go developer, right? And this is where we spend a lot of time. For example, when we do Python, we use async.io, which is built in Python. When we do .NET, we use await async from .NET, and so on and so on. So it's more about the kind of being very, very close to the your tools, because then you use your IDE because you just write Java or Go code. You can use your CI/CD pipeline. You can use your existing unit testing framework. So you can use JUnit in Java, for example. So practically being as close as possible to your natural tools. You just write code, and we provide all this experience for you without requiring any additional hoops.
Mm-hmm. So it sounds like there's essentially a lot of intention around the language level support that you're providing with your SDKs. I'm assuming these are like handcrafted to be idiomatic of the language rather than something that's like auto-generated from SDK automated.
That's why we don't. SDK investment is extremely high kind of effort investment for every new SDK. So that's why, for example, at Uber only had 2 languages, Java and Go, and it took us years to get all these 6 languages. .NET, for example, is still not in is still in preview mode, like alpha. It's not production yet because it took us pretty long time to get there.
Mm-hmm. And then you mentioned, as you were describing, like how essentially Temporal works, is you talked about essentially like you're calling sequence of functions, one of that potentially run on different machines. Machine goes down, and it'll still essentially preserve the state and be able to return that call at some point. So can we get into the details? Like how does essentially the product prevent like data loss in the case of something like a machine dying?
So obviously, I don't have time to go to every like low-level technical details. But conceptually, what happens is that we have a backend cluster. We call it temporal service, and then temporal service relies on a database. So in the open source, we support MySQL, Postgres, and Cassandra. Technically, there is a binding API. You can add more bindings if you need to. Then when you write your application, you take temporal library and link into your application, and then you just write this business logic, and then you deploy your code. We don't run your code ever. It's just even if you use our cloud service, you run your code, you own the workers, you encrypt all the payloads before you send to the service. But then what happens is there is this interaction. So practically we record the process state. And what it means is that if process dies, we can recover on separate machines. So we automatically kind of detect which machine is available. And the state is in the database. So it means that even if the cluster goes down, all your worker processes, we call them worker processes, which contain the business logic, go down. So the state will be in database. Assuming the database is not corrupted and everything comes back eventually, the state will be recovered and will continue executing. By the way, even if the database is corrupted, we already have multi-cluster, multi-region support. It means that you can lose fully region with database and everything, and you would be able to continue executing those functions in a separate cluster.
Mm-hmm. And who owns the database in this scenario? Is this the customer or is this you guys as a managed service?
So when you do use our open source includes both service and the SDKs. So in this case, we call it self-hosting, like obviously. So the self-hosted version means that you run the database, you run the cluster, and you run the workers. If you're using our cloud product, we run the database, we run the service, and we just give you endpoint. It's a gRPC endpoint, possibly through private link. And then you run the workers which need to connect to this gRPC endpoint. We actually wrote our custom database, which is very highly optimized for this use case for our cloud service. But it kind of uses the same bindings. So practically from the OSS point of view, just another database.
Mm-hmm. And then are there situations where like a rollback needs to happen?
Yeah. Okay. So when you say rollback, obviously there are a lot of layers, right? So, but let's talk about application logic, the way people use us. Practically, think about it. You write the function, and we guarantee that this function will complete. Imagine you are doing money transfer. You say, take money from one account, put money in another account, and then account ID of the second account is wrong, and you already took money. So you need to return it. So people kind of call it saga pattern when they need to run compensation. And this temporal is very easy because it will just kind of say try catch block around second call, and in the catch block you can go and execute the compensation. So because we guarantee that this code will execute, including error handling logic, running compensation becomes as simple as just coding basic business flow of that compensation.
I see. And then what are some of the like common use cases that people use Temporal for?
Oh, it's actually a question which people get confused about because we have very generic technology. We practically allow you to write reliable, resilient, distributed systems. So it applies everywhere when you need resiliency. It's not about specific use case. It's about every time you need to make sure that this business process completes. It can be very fast. It can be hundreds of milliseconds. So if, for example, instant payments, or it can be something which runs for months or even years. We are a good fit. So, but it's all about guarantees. But from like specific use cases, it's everything. For example, we have users which need to upgrade Linux kernel in their data center. So rebooting every machine is a flow, right? You need to implement that. And that is something which actually we call these durable execution functions workflows. So just for legacy reasons. So rebooting every machine is a workflow in the data center. But then deploying applications to Kubernetes clusters is a workflow. Rolling out new data centers or rolling out and managing Kubernetes clusters is a bunch of workflows. HashiCorp Cloud uses that, for example, to orchestrate the internal process in their cloud. But then you go up the stack, payment systems, money transfers, instant payments, customer onboarding workflows. Practically, if you take a bank, probably 90% of what they're doing is a bunch of workflows, and we can solve all of that as a single unified solution. We have banks which are standardizing on Temporal as a practically backend engine right now. Mm-hmm. And then you go up you start doing whatever is your business, right? If you're Airbnb, probably it will be booking process, right? If you are DoorDash, it's probably delivering orders, and if you're Uber, it's almost everything. So it applies to almost anywhere when you need guarantees.
Mm-hmm. Yeah, so it's essentially giving you a simple way to put guarantees around the execution of some, essentially service or function, or it could even be like a third-party service, like a payment Absolutely. System or something like that.
Absolutely.
And what about, machine learning? Are you seeing essentially, there's obviously a lot going on in the world of AI right now. Is that something that you're seeing more use of of Temporal in sort of ML workloads?
Yeah, we have an internal joke about that because last year it was a lot of crypto workloads.
Yeah.
And this year we're getting a lot of machine learning workloads. Yes, absolutely. Because we are kind of infrastructure, right? So there is a gold rush there, but we are providers for that gold rush. But think about this way. Temporal is a control plane. We are not big data system. We're not machine learning system. We don't have any vertical solutions. But a lot of companies and startups build vertical solutions on us. We are a perfect system to build end-to-end solution for your machine learning training, for example, and deployment and orchestration. So existing solutions, they're usually piecemeal, right? Like, we can do this, for example, sequence of step, and then you need to use cron, or you need something else, and then you need to link these things together. With Temporal, for example, some of these functions, like workflows, they can be long running. They can be always running and just react to events, more like durable actors. So you can implement the full life cycle. So if you have a model, you can have life cycle of a model which lives for years. You deploy it, you retrain it, you get it back, you get new data. The whole life cycle can be implemented through Temporal. And this is where a lot of companies kind of start using us because it's pretty amazing that you can have just one backend solution for all your needs.
Mm-hmm. Yeah, that makes sense. Especially in given the level of the amount of servers and sort of the distribution models that people have to be using to run some of these machine learning workflows or training cycles right now is massive. So they need some level of guarantees of execution.
Exactly.
How does the actual managed service deployment work? So is this essentially, if I want to use the managed service, am I running that as like is it like a multi-tenant model, single tenant model? Like how am I sort of connecting my code base to have Temporal available to me inside like AWS or Google Cloud or wherever I'm sort of running my services?
So we try to make it real cloud service. What I mean by that, we actually it's a real serverless. We hide all the underlying complexity. So you don't see clusters, you don't see like any underlying machine. So it's like the same like take as free, right? Or like SQS. You don't know what's behind those, right? It's just a bunch of APIs which work and scale. We are trying to do the same thing. So for example, when you go to our service, you provision so-called namespace. And this namespace is just a logical bucket, right? Like the same thing as bucket in S3. And then that namespace is used to implement your application. And right now we give you practically DNS address for your namespace. And what you can do is just specify that address and obviously the security certificates because we need guarantee MTLS. And then you just can start using that. So you can write this code from your laptop and just connect to our cloud and it would work. So there is no difference between open source and the cloud besides the address.
Mm-hmm. I see. And then in terms of, is there a sort of, I guess, like as a managed service for companies like that are going to be security conscious? Are there certain security guarantees using the managed service?
Yeah, I think that we actually have extremely awesome security story. And it's amazing because you come to any large company and say, we want to run, they practically say, we want to run our core business workload on you. And we are, okay, you use our cloud. And they, no, we don't do cloud, right? It's like very standard reaction. Security, PI, all these things. And then we go and talk to them and explain our model. And we are practically able to close almost every large company and pass their security reviews without problem. Why? First one, we don't run user code. Because all these worker processes, which contain both workflow and activity logic, like all this logic, they are running in always user data center in their VPC and using their deployment system. We don't even know how they run. Secondly is that before sending any data to the cloud, you can control encryption. We have pluggable component. We call it practically data. It was called data converter. I think data, now it's called data something. But the idea is that you can specify your own with your own keys, with your own encryption algorithm. So you fully own encryption. And we never need to look into the payloads. It's different from database. For example, if you have database in the cloud, you have to put data there because database, the way it functions, it requires database. We are more like pass-through. You encrypt data, you give it to us, we give you back encrypted payload, and then you can decrypt it any way you want. So even if you put PI there, which we don't recommend anyway, but you control encryption and you trust encryption, you can trust Temporal. And then also, you don't need to open any ports or anything in your firewall because all connections to Temporal are outgoing to our cluster. So practically all your SDK needs is practically connection to Temporal gRPC cluster. And this is it. So we don't run your code, you encrypt everything, and all you need is connect to us, and you also can use private link to connect to us. This is usually enough to practically, even for very security conscious organizations. Obviously, we also have SOC 2, Type 2, and all these other things, but the most important one is just our security model in the actual product.
Right. Yeah. So you're never ever seeing the code or executing it. Essentially, you're just you're a data processor. But even in that context, essentially, all you're seeing is this.
Yeah, probably you can compare us to something like some providers which provide queuing technologies. You encrypt message, you get encrypted message, and what happened there is we are kind of similar in that regard, right? We are certainly much more complex than queue, but at least from payload point of view, it is very similar.
Mm-hmm. Yeah, makes sense. And then in terms of like competition in this space, like obviously, like Amazon has their like project that you mentioned, the simple workflow service. And, Microsoft has their version, but there's not really, to my understanding, like a direct competitor with Temporal other than, I don't know, someone sort of building something themselves. So, especially in the early days when you were starting, you're sort of defining this category of product. So how did you go about sort of navigating that from a go-to-market standpoint? Like, there's always a challenge when you're bringing something new to market that people might not even, they don't even know to look for essentially what you're offering.
It is still a problem because durable execution as a category is a new category. Most people still are not aware about that. More and more, obviously. We just had our conference. We had quite a few users there. Certainly, everybody is super excited about that. But again, we are still not ubiquitous technology. We absolutely want to be there. So that is our challenge. The good news is that after you understand durable execution and you get some experience with that, it's almost impossible to go back. People cannot just go force themselves, just start using old approaches, all event-driven approaches after they learn about Temporal. So all our go-to-market is based around open source. What I mean by that, we don't go around and try to come to company which never heard about Temporal and say, okay, use Temporal. It's more about, okay, if you're part of our developer community, you can come to us and say, I don't want to run, for example, this backend server, own the database. I prefer you to do that. And then we practically just become helping people to run this backend server. But all our adoption, and obviously especially initial adoption, came from open source users and open source customers. And we still have a lot of pretty large companies. Just today we signed one, I don't want to probably name that, but very well-known big company which was using open source for over 3 years, maybe 4 years. And now they just decided to become our cloud customer. So we have some pretty good value proposition there. But at the same time, it's important. Our open source is fully featured. They were able to run it for 4 years successfully because all the features and there is a guarantee that if you run against open source, you should be able to run against cloud and vice versa. So we even want to provide in the future the live migration back and forth. So that is very important guarantee people want.
What is the main reason that people end up sort of switching from, if they start with the open source project, to the managed service?
Usually, if they started from reality is that if you run you run your business critical processes. Imagine if you're doing something even relatively simple, but it's business critical. You need on call, you need the team, you need a database to support that. So organizations which are successful running Temporal at a large scale, not one project, but when you have dozens of projects, when you have large scale use cases, they require a team. They require a team which operates this infrastructure. And you absolutely can do that. Like, there are quite a few companies doing that. At the same time, more and more companies learn with time that just outsourcing it to us. And as we are experts, we know the technology. And we also have this backend database, which can provide you much better scalability and performance. With time, it's actually more expensive to run it yourself than run our cloud. We actually got, because we have this highly optimized engine, if you compare kind of apples to apples, you can end up paying the same, but you get so much more without using our cloud. That's why a lot of companies finally migrate there. But usually it grows with usage, right? If you have just 1-2 use cases, open source is fine. But at the same time, you spend a lot of time learning how to run the cluster instead of. So most companies right now prefer just go to the cloud directly because they always can switch to open source if there is a problem with the cloud. But so far, I don't think we had such cases.
I see. And then, how is the engineering team structured? So you have essentially, you're supporting this open source project. You have your investments from a developer experience standpoint, supporting all the various languages across these different SDKs. And then you actually have like everything that's going into essentially building and running a managed service. So how is the structure of the team shape out?
Obviously, it changes all the time. But one thing we don't want to do, we don't want to separate out very far. I don't want to make this mistake of having this kind of commercial offering versus non-commercial offering, because they will diverge, right? We've seen cases in the industry which actually led to pretty bad results. So we actually want to make sure that core open source service stays exactly the same. And the main features and the APIs are compatible. So that's why we actually have one team building features for open source. And they work closely with the cloud team, mostly around deploying things and making sure that they run successfully. We certainly have a separate cloud team, which deals mostly with control plane, because imagine we already have 12 or 13 regions. We run on AWS only right now, but we started to work on GCP. So we will have other cloud providers soon. And obviously Azure will come after that. So running this huge infrastructure very reliably requires full automation. So we absolutely have a team which deals with this automation, control plane, permissions, routing. And then we have infra team, which deals with kind of underlying infrastructure, and there are a lot of concerns there. Just one idea is that as we run a multi-tenant service, metrics is a problem because we have so many dimensions. Imagine if you have 100,000 customers in the future or more, and then metric engines don't like high dimensionality of those. How are you going to provide metrics to every customer? But at the same time, if there are so many customers and there are so many namespaces, these are type of problems we have to solve on a kind of infrastructure level. And then we obviously have SDK teams, which directly deal with these open source SDKs. And they work with kind of customer facing features all the time.
And in terms of like I feel like this is behind the scenes, very complex engineering project with a lot of moving parts to do this at scale with all these guarantees. Like, what is some of the hardest sort of engineering problems that you've had to overcome?
I think the hardest one is reliability and resiliency, because we cannot lose data. We cannot lose even single task because the transaction will get stuck. So just making sure that, for example, it works with existing databases and we can work around their limitations. That was actually very, very extremely hard. Like guarantee consistency, we are fully consistent service. Guarantee uniqueness and still provide reasonable throughput. It was extremely hard. For example, one of the offerings we have is we run on top of Cassandra. Cassandra is an awesome tool to do highly scalable kind of transactional. Actually, not very transactional. It actually has problems with transactions. Exactly right. But if you need scale a lot, Cassandra is very, very good. But it's a very sharp tool, right? It's very easy to cut yourself. Like you don't want your developers directly using that. We spent a lot of effort just making sure that we can implement all our business logic on top of that very efficiently. It was extremely hard. And then the other part was certainly around developer experience. I think the hardest part wasn't even making this system scale, but making sure that people like our APIs and they are natural and the learning curve is not insane. So I can guarantee you, if you ask me about any field in our API, besides there are thousands of them, I can explain why it's there. Because a lot of thought was put into our APIs and execution models.
Mm-hmm. How does the like API design sort of come together? Is it sounds like a very important part of like your success and adoption is having like great APIs, great SDK, great developer experience. So how does that design sort of come together? Like where does that begin? And are you following sort of API design first philosophy? Like what's sort of the product design cycle?
Yeah, here API first is the only option. There is no other way, because our API, for example, which we present to the users versus API which we use internally or even on the SDK, and API of the service, they're absolutely different APIs. They're not related in any way. They are very, very far apart. The SDK is a very complex state machine. It took us over 1 year to re-implement with a pretty good team. And so, yes, it was API first. But it was a lot of iterations. I wrote probably 5 or 6 client-side frameworks for that. And first attempts were pretty common to what we have in the industry. It was more like kind of similar to step functions and stuff. And I quickly learned that these things don't scale in complexity. You cannot write really complex applications using any kind of YAML or JSON or any other kind of, even if you instantiate objects in code, like abstract syntax trees in code, it doesn't work. And our solution was just write your code, and your code is fault tolerant, and you don't need to do anything else. It just code out of the box is fault tolerant. But it took some time. And then we wanted to make it as natural as possible. For example, a simple workflow forces you to do full asynchronous Java. And as we know, Java, especially 10 years ago when we did it, didn't have any support for asynchronous code, like good asynchronous code. So we had to invest all our own framework to do asynchronous code. The problem is that Java developers don't understand asynchronous Java code because it's not a thing. And then you give it to them and they get confused. Now we actually were able to implement Java, which actually provides normal synchronous Java code, blocking API calls and everything. And it's natural to people. And that's why we've got such a good adoption there. People like that. But when we can use async, we use await async in .NET. We use async in obviously TypeScript. So if we can leverage normal language constructs, we will do that. But if it's not natural for the language, we are not going to force it on people anymore. I think this was main discovery. But then it's a lot of details. Like every API call, we think through very, very carefully.
Mm-hmm. And then in terms of the, one of the other things that you mentioned in terms of the challenges is essentially like the uptime and the consistency and guarantees. So what are sort of the uptime and like latency guarantees that you're giving to companies that adopt the managed service?
So practically, okay, this is actually one area when there is a lot of confusion. We are very conservative when we give these estimates because we kind of came from the big companies like Amazon, and we measure per request uptime. I know a lot of services just, if services are like reachable, it's uptime, right? But given how we position that, I think for request, we give, I think, 3 nines on a single region. But for like total service uptime, we give 4 nines. But with new multi-region capabilities we are given, we will be able to give 4 nines or even higher, maybe in the future, for highly critical applications, even in presence of failures. But we are working on that right now. But again, I don't like these nines in general because people have very different kind of view on them, right? Like we want to put them out and we want to explain what they are. But usually we explain people how we operate, how a system works, and we give them more details, and they're comfortable. Even, for example, if I say it's 3 nines, but people understand what we mean by 3 nines. People are much more comfortable than like just throwing a number out. I see too many people just throwing these numbers out and without actually understanding deeply what it means.
Okay. And then as we start to wrap up, is there anything else you'd like to share? What's kind of next for Temporal?
I think the most important thing for us is getting adoption. And please, if you never heard about us before, just please go to our website, temporal.io. Actually, we just last week got a .com site, so there is now temporal.com, which will probably redirect to temporal.io. But go there and try to understand durable execution. You don't try to understand the model. After you understand the model, I can guarantee you certainly will consider it for your next project. I think this is the most important thing for us is just getting. But then our goal is becoming ubiquitous because I believe every company should at least understand what's there and use it. And then we have a lot of plans in terms of specific features, specific things around availability, more clouds, and obviously growing the business. But so far at this point, I think the most important thing for us is just more developers learning about us and getting converted to our way of thinking about the backend systems.
Awesome. Well, Max, thanks so much for being here. I think you're solving a really hard problem for people, and it sounds like in a way that is like easy essentially for the adopter of the technology. So I think it's an exciting thing to talk about and to learn about, and hopefully people who are listening will go and check out the new .com site and try it out.
Awesome. Thank you.
Cheers.